Okay, let us begin. Today's lecture will be about innovation and culture, and we will be ending the first half of the course. It's a midterm period, and then we will move in the second half of the course on specific methods, techniques, and practical aspects of innovation. So two areas that we'll be discussing today are the divergence between East and West, culturally speaking, with respect to innovation, and also some examples of innovation culture in Silicon Valley, the United States, and in the startup communities, startup ecosystem, sometimes called Startup Nation in Israel. And the second lecture, which will be separately recorded, will be a specific discussion of some aspects of innovation as they pertain to chaebols in Korea. And hopefully with these two lectures, we'll get a good understanding of some of the cultural aspects related to innovation, both historically and in the present time. So as I mentioned, we are in the first half of the course. We've talked about what is innovation. We've given many examples of the history of innovation. And now in culture two, in other words, last time we talked about the scientific method as a kind of cultural framework for innovation. We'll be talking about East and West, Silicon Valley Startup Nation. I also want to mention, and this link will be in the notes, of course, that you can click. As I sent you in the Kakao Talk message to the group, one of the companies I'm working with, Flight, became second out of 175, about 175,000 entrants in the Entrepreneurship World Cup. The finals were in Dubai. And as you know, we had won the Canadian finals about 2 weeks ago and were in the top 200. Then they had a round for the top 100, then the top 10, the top 5. And then a few nights ago was the final pitch. And the CEO pitched Dan Cohen, and Flight won second place with a $250,000 prize. So I encourage you, all of you interested in innovation and in startups in particular, some of you may start your own companies, to go to the YouTube recording of the pitch, of the presentation, which you can click on here, and that will go to Dan Cohen's pitch, which is really outstanding. That was actually the one for the Canadian finals. And I think this will be a very good framework for you to study and learn from how to do a very good pitch. The other thing I wanted to go over quickly is the special projects for the class. We don't have a midterm exam, as you know, and we don't have a final exam, but we will have these short projects. And they will basically be about one, maybe two at the most, but 1 page short reports that you will send to me by email, and I'll send you an email that you reply to with that with your assignment. So the three projects are, the first one is curiosity. So this course is not just about some abstract or theoretical concepts in innovation, but is really about creating a mindset and a feeling for innovation. And the other part of the course, the integration of science and art with the book Waves, as you know, is also to get this out of the box feeling and not just to focus on the technical side, but the whole spectrum of skills and abilities and philosophies necessary for true innovation, not just creativity, not just a fancy idea, but to really make new things happen in the world. And that requires, as I mentioned, the science and art integration. But some of the mindsets that are very important for innovation are curiosity. And so the assignment is to attend a webinar. So now during this COVID era, there are many webinars. You can find them on your social media. You can go to the website at the school and so forth, and you'll see webinars being announced, and many of them are free, of course. And I would like you to attend one of these webinars, and it can be a webinar in Korean or English, and preferably outside your area of interest. So if you're interested in chemistry, go to a biology webinar. At DGIST, there are many seminars and webinars available. So you have a very special opportunity to attend these webinars, or they can be outside DGIST as well. So attend a webinar, preferably outside your area of interest. And then write a short paragraph or two about what you found interesting and what you learned. And the due date for this assignment, and again, I will send you an email which you reply to with your attachment, is Friday, December 4th. The second project, so the first project is about developing curiosity. So you want to just go out and see something new and learn something new. So write a short paragraph about what you found interesting and what you learned. Now, the second project, due on December 11th, is about observation. And we had seen examples in history of Leonardo da Vinci and Michelangelo and Galileo and so forth about observation, and not just seeing something and saying, okay, that's whatever, but to actually be interested in this unusual observation and think about it. And maybe that has some implications for innovation. So take a walk inside or around your home, in the neighborhood, and keep an eye out for something interesting, strange, or mysterious, something that caught your eye. And it doesn't have to be, seeing ghosts or something. It could be something very regular, but you found it unusual. And write a short paragraph or two about why you found this interesting and what new knowledge or new innovation this observation could lead to. You can also share video or a picture as part of that observation. And in a later lecture, I'll give you some examples from my experience of this kind of observation. The third project is a passion to make an innovative suggestion about improving the online educational experience at DGIST. So we have had a lot of challenges, and with challenges come innovation. When life is normal, people don't have as much incentive to innovate. But when life is not normal, then innovation is necessary. So we've had this online educational experience, not just at DGIST, but at many schools. And I'd like you to write a short paragraph about an idea you have to improve the online educational experience at DGIST. And again, this is a mindset. If you don't think about improving something, if you think everything's okay and you just go through the motions and just live life as other people just offer it to you, you will never innovate. You have to think about something that may seem perfect, may seem fine, or perhaps you don't think it's perfect, but you actually have to think about how to make it better. That's the passion for innovation. Now, I don't want you to just list the idea, but you should have some simple plan. It doesn't have to be a whole pitch or a whole business. Some path or plan to making it real. Remember, innovation is not just creativity, but actually making a change as a result of this new idea. So again, 1 or 2 paragraphs with a diagram, if you wish, will suffice. And the due date is the final date of the class on Friday, December 18th. And based on these suggestions, I will compile these innovative ideas and present them to the DGIST Dean of the Undergraduate College. In other words, this innovation class is not just about you learning, but this innovation class can be a source of innovation for DGIST, your community. And that again is emphasizing this aspect of passion. So attending this class will make your life, not just you learn something, but will make your life and other people's lives better. And that's what innovation is about. This is an innovative class about innovation. So really think about it, and this will be a very exciting project to submit. Now, with the second part of the course about waves, as you know, there is another final project, which will be artistic work, a literary work or musical work related to science. And I will give more details about that in the next lecture. But these are the short projects, just one-page projects about curiosity, observation, and passion. And they're very important projects, even though they're short, because your grade will also depend on this, as well as attendance and participation and so forth, and the final project. On the surface, they are very easy projects, but they will require some thinking and for you to be outside your normal box, walking around, observing, going to a webinar, and thinking about how you can improve your current situation directly. So let's now review a little bit about what we did last week. Now, that lecture was about innovation culture, part one, and we focused on the scientific method. The scientific method is a way of understanding the world, and it is a culture. It's a way of understanding and changing the world. So the scientific culture, as embodied by the scientific method, is a method of innovation because you discover new information and new things come out of that. So it's very important. And of course, many of you are aware of this, but I think it's important to summarize this. Innovation is not just a business concept, but it's, as I mentioned, a mindset. So what is science? Science is the intellectual and practical activity encompassing the systematic study of the structure and behavior of the natural world through observation and experiment. So I've highlighted the key words here. It's an activity, it's intellectual and practical, it's systematic. And for example, you write your second project on observation. That's not systematic, that's just one project. And I ask you to write one paragraph about that. But if you took that same phenomena and observed more and then did some further observations and maybe looked at from different angles and so on and so forth, systematically, you would be doing science. And then, of course, another key word is the observation experiment. A central part of science is the concept of a hypothesis. And the hypothesis is interposed between facts, which we observed, and then hypotheses, when validated or tested, become scientific theories. So this hypothesis is in the middle here. And a key difference between a hypothesis and a guess, because fundamentally a hypothesis is a guess how the world works based on the facts. But the difference between a hypothesis and a guess is that a hypothesis is testable or must be falsifiable. So in other words, this actually is not an easy thing. And this is where the artistic aspect of science comes in, because a hypothesis is not just something that comes out of a formula, 1 + 1 = 2. Hypothesis must be focused enough to generate general ideas when validated, but not so broad that it essentially cannot be validated. So there's an art, there is a non-scientific, if you will, non-objective way of making these hypotheses. And that's at the nexus of that is the artistic aspect of science. And as we know, Einstein wrote, after a certain high level of technical skill, and many of you do have great technical skills, but you're maybe not necessarily, full scientists yet. Science and art tend to coalesce, and so other aspects of aesthetics, what looks beautiful, theories being beautiful, plasticity and form, the greatest scientists are always artists as well. And so what we develop in this course, that sentiment or that feeling, is extremely important for high-level successful science. Now, we talked about the intersection of science and art, but there's also the intersection of science and technology. And in our lecture, just by way of review, we had talked about how the modern innovation structure about the universities doing basic science and industry doing applied science was established at the end of the World War II and the post-war era, largely by the efforts of this man, Vannevar Bush, who wrote this report to the president called Science, the Endless Frontier. And of course, he's an American, and that influenced the American system. But that concept has been propagated in all of the developed world, including Korea. So we have DGIST and universities like that focusing on pure science, uh, and companies working on applied science. But that concept that has been separated by Vannevar Bush is actually much closer together than we thought. And the concept is science leads to technology. But as I argued, technology can also lead to science. And the example of Einstein comes to mind. He is the epitome of the pure scientist. Everyone aspires, every scientist says, I want to be like Einstein. He did all this pure science. He wasn't a businessman, he wasn't an industrialist, but he was actually very practically informed because, in fact, he wasn't a pure academic. He was actually, at his time of some of his early discoveries and biggest among his biggest discoveries, was working in a patent office in Switzerland. And of course, he described how the patent office enforced this practical thinking and many-sided thinking. Now, what was interesting about Einstein, even though he was pure science in terms of relativity theory and so forth, his science was informed by the technological developments of the time. In other words, electricity and the railway, which created a need for synchronizing clocks. In other words, to get trains on time in the famous punctual Swiss railway system, you had to synchronize and make the clocks in different stations uh, coordinated. And of course, that intersected with the technology of electricity, which was also fairly new, and rail technology, electricity technology coming together to hopefully solve this problem. And at that time, of course, since he was in the patent office, he received many patents about synchronizing clocks. And in fact, there's a book in Korean about Einstein and this concept as well. So he was very practically oriented. And so pure science is important. The scientific method is important, but it doesn't necessarily lead to innovation. And pure technology needs, of course, to be informed by the scientific method and pure science. So there's a two-way intersection between them. Now, we gave some examples last week on some industry examples of innovation. And one of them was the company 3M. It's an American company. It also obviously does business in Korea. And the 3M way, we talked about some examples of masking tape and so forth. But to summarize, the 3M way was that 15% of all the employees' time is allowed to be on their pet projects, completely independent, free time. For Korean business, I've worked in Korean business. I've worked at Samsung. I've worked at smaller Korean companies. This is a very unusual concept. In Korean work, you're supposed to sit at your desk and 100% of the time work on exactly what the company wants you to work on. And that's not intrinsically bad. I mean, Korean companies are very uh, effective and they can be very successful, but that doesn't necessarily fit with innovation. And so 3M is famous for innovation, all those thousands of products that we talked about, some of them. And some of that comes out of this 3M way where people spend time, by Korean standards, wasting their time. If you go to Samsung and you spend 15% of your time just walking around thinking, your, kwajang or chajang, your manager is not going to be very happy, and they may, fire you. But that's the problem is there's a tension between innovation and efficiency. So that 15% is wasted. Yes, it's inefficient, but it's necessary for innovation. And so why is this important? Because innovation usually challenges existing procedures and norms. So if you're spending 100% of time on the existing procedures, it's virtually impossible to innovate. And then we talked about disruptive innovation, very important concept in innovation, which we introduced in the first lecture, of course, and we're giving some more examples. And there is the concept of disk drives. These disk drives are getting more and more obsolete with solid state drives, but the disk drive is basically a magnetic surface and a reader that reads the digital codes there. And disruptive innovation, as you know, has disruptive technologies with lower performance, eventually reaching a point where they reach the market expectation of performance, performance demanded at the low end of the market, and this disruptive technology with the lower performance, less effective or less performing technology can then replace the higher performing or sustaining technology. And we saw that example with disk drives. So the technical developments in disk drives were the read-write head, and then also the architecture. And most of the technical developments in these areas were what we call these sustaining innovations that are constantly improving the product. And they were sustaining because they kept the existing manufacturers and the existing markets stable. So even though the innovations might have been incremental or radical, expensive or cheap, software, hardware, whatever it may be, they were sustaining. So a major characteristic of the sustaining innovations at the high end is that the leading companies continue to dominate. The business is not disrupted, and the progress occurs over historically predictable lines. But then we had a disruptive innovation. Disruptive innovation was not in the architecture, it was not in the technology. As we said, the read-write heads, those technical developments constantly getting better. The disruptive innovation was quite simple. It was just size, going from 14-inch large disks to 8-inch. So the technology was the same, the size was smaller. And it turns out that those smaller size were less good. In other words, they hold less data. So the market doesn't want less data. And they were a little bit less reliable for physics reasons and technical reasons, engineering reasons, and whatnot. But they created an entirely new market because the mainframe, the existing customers, large computers, wanted the 14-inch or higher, whereas in the 1980s, the personal computers came into being. And of course, they needed much smaller disk drives, even if they were less capacity and less reliable, so lower performance. And they displaced the ones producing the inferior disk drives. Uh, they're not bad, but they are not as high performance as the large ones. But the companies producing the smaller disk drives eventually replaced the industry leaders who constantly improved the larger disk drives. This is a paradigm of disruptive innovation. So that's the review of last week. And now we'll talk about innovation culture 2. And we'll talk about three major things, what we call the Great Divergence, the divergence between the East and the West in the 19th century and part of the 20th century. And then we'll talk about Silicon Valley and Startup Nation. And both of these discussions will relate to this lecture will relate to the special seminar that will be separately recorded. So what is the Great Divergence? This is a chart since the Middle Ages, 1300, of gross domestic product per person, kept at 1990 constant dollars. And you can see that since the Industrial Revolution, about the 1800 or so, GDP has grown exponentially. People have gotten more wealthy and so forth. But the growth has not been equal. China and India, which are in red and beige here, were lagging until just the last 30, 40 years. Essentially, they were back in the Middle Ages. Now, that sounds very harsh, but that's the reality of the GDP. Now, of course, we're not talking about the quality of the societies and whatnot. This is just a strictly economic figure and economic measurement. But it's quite different than Europe and then to a slightly later extent, Japan. Korea is not included in this. This is just these countries that are listed here. And of course, Korea is matched in this level. And of course, India and China have also increased. So this is not a discussion about the present time. This is a discussion about last century in the 1900s. And why was there such a difference? And this difference has been called the Great Divergence. So before 1700, before the Industrial Revolution, these GDPs were quite similar. But because of this change, the factor of GDP differs quite significantly between these countries. Now, roughly speaking, that's the West and that's the East. Why was there such a great divergence? So there are some issues. There's an ongoing debate why England was the first to industrialize, but there's some consensus that institutions played a significant role in determining the timing of a country's industrialization. So this is a very complex topic. We can write a whole course about this, a whole book, and there are books about this. But what are some of the reasons? It could be physical environment, European climate, and environment was fairly stable. It had access to the sea, and so there could be a lot of connections and trade and learning new ideas and innovation that helped drive this industrial revolution. Another factor could be culture and religion. Asian cultures favored obedience and not, changing things and not uh, going against authority, the so-called Confucian ideal. Not sure that's a very major factor because in actuality that has also been experienced in the West. Anyone who's read about Galileo and knows about Galileo knows that he was forced to recant his opinion about the sun and the earth and the sun being at the center uh, under pressure from the Catholic Church. So, of course, there are obedience issues, if you will, in the West as well. And then political and social institutions. The Asian institutions were more authoritarian, particularly the Chinese Empire and so forth. And in Europe, there were multiple small states. There was a rule of law and property rights, and some of these things that enabled more flexibility that fostered innovation. And that may be a reason. Markets were fairly well developed in both, so that's not considered a major region. And then, actually, in terms of technology, as we saw, many innovations, at least in an isolated way, came in Asia before they did in Europe. The printing press, actually, as we talked about in Korea, as well as China, paper, gunpowder, etc., in China, and other innovations actually were developed in Asia before, but this early advantage was not maintained. And I think the major reason for this great divergence, which is not reflected in this table, but the major reason is probably the complexity and interaction of the ecosystems. And in Asia, these ecosystems were less able to interact. And we'll go into an example of Silicon Valley. So, Silicon Valley is often touted as the epitome of contemporary modern innovation. And Silicon Valley is not just one place, it, of course, is many places. It has social media innovation in San Francisco. It has biotechnology in South San Francisco, software more south of that, a very well developed uh, venture capital community, startup central down near San Jose, and then across the bay in Fremont, there's a lot of industry and manufacturing and factories and so forth. So Silicon Valley is a very diverse community of many different types of startups, many different types of uh, businesses, and not just an incubator, as it were. So it's very diverse over space, but Silicon Valley is also very diverse over time. And so the term Silicon Valley comes from the fact that many of the integrated circuits with Fairchild Semiconductor and Intel were developed in the region. in the early days in the 1960s and 70s. And so that's, of course, based on silicon, Pandoche. And so these integrated circuits gave the name Silicon Valley. But of course, that's not the center of integrated circuit design now. Where, and Silicon Valley was a hub of innovation before that time, and they had various waves of different innovation. Vacuum tubes in the 1920s, test equipment during the World War, microwaves in defense during the Cold War in the 1950s, the integrated circuits as described. Then personal computers, life sciences started to take off in South San Francisco, the internet, clean tech, and social media. And now we're seeing more AI and other types of innovation. In Korea, we often create these incubators around specific industries, and we want them to be like Silicon Valley. So in Pangyo, we have gaming. In Gangnam, we have fintech. But it's important to note that these are not static. And so Silicon Valley is not just integrated circuits, of course, and it's not just social media, but it has had variability over time. So complex ecosystem over space and time. The other very important thing to keep in mind is that Silicon Valley was very focused on disruption. So we gave those examples of disruption, in particular the disk drive, which are not necessarily related to sustaining innovation. In other words, incremental innovations or radical that keep the status quo, but disruptive innovations that completely change industries. So this is the Silicon Valley ecosystem, and you see the uh, main sectors in light blue out here and the disruptive companies in dark blue here. These are very large markets. And so disruptive technologies become very important focus in Silicon Valley. And so a lot of uh, innovation centers focus on incremental innovation. So, for example, in Pangyo, the gaming industry, sure, there's a lot of innovation there, but you have a gaming center and you're not going to replace the games with something else. You're going to just produce better games, new generation games, and so forth. And so that is, yes, innovation, but it's not quite the disruptive innovation that is characteristic of the most innovative places. Now, we talked about the reason for the East West divide, and I mentioned about ecosystem and many different groups coming together in diverse ways. And we talked about the diversity over space and time of Silicon Valley. And so, Silicon Valley is not just an agglomeration of startups. In fact, the startups are quite small uh, component of Silicon Valley. Most of it is actually venture capitalists, angels, mentors, peer networks, legal, intellectual property, accounting, banks, IT. There's a whole ecosystem that supports this activity. And all of those different parts have to come together. So you remember our definition of innovation in the beginning, the very first lecture. Innovation is not a new idea, it is the implementation of a new idea. And to do that implementation almost always takes multiple skills and multiple capabilities. And if you don't have this diverse ecosystem that's working together, you cannot have innovation. Now, there are two aspects to this. One is you have to have the diverse community. Second is they have to work together. So if you create a Pangyo and you just throw a lot of lawyers there and a lot of accountants and a lot of venture capital and you throw in a lot of startups, but they're not working together easily, then you will not get innovation. So those are the two characteristics. Now, very briefly, we'll talk about Startup Nation Israel, which is another example of a very high uh, density of innovation. And this too has a great diversity of different companies and large and small and so forth in different regions that focus on different areas, but they also interact. And so, what are some of the reasons for Startup Nation? Again, the same as Silicon Valley, a startup ecosystem with many diverse components that are able to easily work together. And there are few barriers between them. So these include corporate spin-off R&D. We saw some of those examples, research institutions, incubators, academic institutions, a innovative entrepreneurial culture, experienced entrepreneurs, support of government, strong venture capital, and also defense technology spillover. So all of these coming together and easily working together. So the second half of the lecture, so we'll take a break for a few minutes and then we'll start again, is actually a special seminar that I presented last year at the ASIALEX, which is a leading innovation organization community, and they have an annual conference based in Asia. And this annual conference last year happened to be at Tsinghua University in July. And I presented on the historical development and ascendancy of family-owned business conglomerates in Korea, called chaebol, as an adaptation to cultural transaction costs. And then at the end of this seminar, the implications for new models of startup-driven innovation. That has been a big challenge in Korea, the chaebol and startups and innovation and how does this all happen. And in this seminar, which is an academic seminar, I also try to give some practical implications for this. So that's the end of this lecture. And next week, we will start with the methods of innovation. So when I mean next week, next Friday, we will actually just take a short break and start with this special seminar in a few minutes. And we'll start with, in terms of methods of innovation, we'll start with the neurobiology of creativity and learning. So we're going to go back to biology and to understand how does the brain learn and how is that learning related to creativity. And these concepts will give important insights into how we personally can innovate and also organizations can innovate. So that's the beginning, the very core of methods of innovation. We'll start with a little neurobiology. So that's the end of today's lecture. Any questions?